are called as periodic properties. The first property is about valency or valence. So what is actually valency? Valency is the capacity of an atom, right? That atom combining with the hydrogen or oxygen. So the combining capacity of an atom with respect to hydrogen or oxygen. So that we defined as here valence or valency. Did you remember Mendeleev also classified that elements based on the valency. So valency is important to know the characteristic properties of the elements. Characteristic properties of the elements, right? So here, that's why we are giving importance for the valency, right? So here, just that valency with respect to hydrogen. How to calculate that valency respect to the hydrogen atom. So in case of hydrogen atom, just we are counting the hydrogen atoms combined with particular atom. So number of atoms combined with XYZ element. That count of hydrogen atoms only given as it's a valency. So valence of an element with respect to hydrogen is simply the number of atoms with which one atom of the element chemically combines. For example, here I am giving you one composition. That is what ammonia, NH3. So what is the valency of nitrogen in ammonia, NH3? So here around the nitrogen, how many hydrogens are there? How many hydrogens are there? 3. So the valency of nitrogen is taken as 3. Right? Valency of nitrogen is taken as 3. Suppose if you are taking the composition with respect to oxygen, right? That count of oxygens are making doubled here. Valence is twice the number of oxygen atoms with which one atom combines. For example, here composition I am taking here calcium oxide. So what is the valency of calcium according to oxygen? So what we need to do, just double it, double it. So how many oxygens are there in the composition formula? 1. So making double into 2. So 2 is valency of calcium. 2 is the valency of calcium. So like this, you are calculating the valency, right? So doubled because count of oxygen is 1, double 2, double 2. Then here, my question to you, I am giving you one of the composition H2O, hydrogen monoxide or water, right? So now tell me the valency of hydrogen and tell me the valency of oxygen with respect to other element. With respect to other element, following the same logic. Following the same logic. Valency of oxygen respect to hydrogen in H2O. Give me answer for this question. What is valency? Combining capacity of an atom with respect to hydrogen or oxygen. Okay, here I am asking you oxygen valency respect to hydrogen. So that what we are following, just we are depending on the count of number of hydrogens, right? Combined by oxygen. So how many? 2. So oxygen valency is what? 2. Then valency of hydrogen with respect to oxygen atom. So what to do? If you count oxygen atoms, make it double. Sir, hydrogen monoxide completely with 1 oxygen atom, sir. So if I doubled, I'll get 2 2, sir, but not the valency of hydrogen. It is not the valency of hydrogen. But here you need to understand one logic here. How many hydrogen atoms are there? 2. We required only 1 here. So 2 are combining with 1. Then what about 1? It is half. Then making double. What it will give you? 1. So count of oxygens are 1 here. Then here you are taking that valency of oxygen is here simply 1. Sorry, valency of hydrogen with respect to oxygen is 1. So similar logic you can follow here in finding a valency of sodium with respect to oxygen, Na2O formula. 2 sodium atoms, 1 oxygen, right? 1 oxygen. What about 1 sodium with respect to oxygen? So 1 by 2 into 2. So that will give you 1. So like this you are finding. Are you clear about this concept or still in confusion? Clear? Clear everyone? Right. So practice it. Practice it. Okay. Then one more question to you here. MgO. Answer about valency of magnesium here respect to oxygen. Give me the valency of magnesium respect to oxygen. With respect to oxygen. Valency of magnesium respect to oxygen. Answer me. Answer me. First. On answering. Here, what to do? Magnesium 1 atom, oxygen 1 atom. So magnesium valency is required based on the oxygen. So make it double. So 1 into 2. 2 is the valence of magnesium. That's it. Clear? Am I audible? Yes, clear. So we'll go for another here. Then we learned about the valency of an atom with respect to hydrogen and with respect to oxygen. Here, that valency remains same for all the elements? No. It varies. Depending on what? Valency shell electrons count. Depending on what? Number of electrons situated in its valency shell. So that electrons count will affect the valency of an atom. So that how valency change in groups and in periods. We are learning that varying of valency, especially in groups and especially in periods. Can anybody tell me about the valency of a particular atom which belongs to the same group? Same group. What we given general electronic configuration for a particular group. For example, here neon, helium, neon, xenon, argon, krypton, xenon, radon, and argon is that. What the general electronic configuration is given? Only for helium, NS2, remaining all are NS2, NP6 configuration. Did you see that? Have you got idea about that valency shell electronic configuration same in the groups? Helium on NS2, okay. From neon, what we can write here? 2s2, 2p6. For argon, 3s2, 3p6. I'm writing only valence shell electronic configuration. Next krypton is 4s2, 4p6. Xenon is 5s2, 5p6. Similarly, you are getting s2p6. But n value is different. So ns2 np6 configuration. ns2 np6 configuration. Right? So this is you need to observe in the groups. So here that the trends in groups, that means changes. What the valency? Is it changes or remains same? Valency in groups. Valency in groups remains same or changes? Observe the general electronic configuration. Valency depending only on the valency shell electrons count, last outermost shell configuration. So the elements which are fall into the same group, they are with the similar valency shell electronic configuration, is 3s1, 4s1, 2s1, 1s1, like this, right? So no change in the valency shell electrons count in the groups. So that's why here from top to bottom, valency remains same. For example, here, sodium is taken. What is its valency shell electronic configuration? 3. Suppose potassium is taken. What is its valency shell electronic configuration? 4s1. Is there any change in the count of valency shell electronic count? No. 1 electron. 1 electron. That valency is same, not changed. Right? So valency simply we are calculating based on the group number also. Based on the group number also. From group number 1 to 4, its group number only given as valency. They are giving their group number only as valency. Right? Then from group number 5 to 8. Right? 5 to 8. How we are finding the valency? Here, this group number is subtracted from 8. 8 minus group number. That will give you valency of the particular group. So here suppose 8th A group is there. Right? 8th A group is there. What is its group number? 8. So subtracting what you will get, 8 minus 8, 0. So that 0 is valency of group number 8. So like this, similarly, you can find out valency of the elements. So here valency is remaining same within the same group. In periods, that valency not remains same in order. So up to 4th group, right? Up to 4th group, for example, second period, starting with the lithium, beryllium, boron, carbon. Up to carbon, valency is increasing by 1 unit. So 1, 2, 3, 4, up to carbon. But later, nitrogen onwards, nitrogen, oxygen, fluorine, neon decreased by 1 unit. So once increased, once decreased. Are you able to express clearly? Sometime increasing, sometime decreasing, it will give you confusion. It is especially in S and P block. If you go for D block, there is no like this order. There is no order like this in D block. So you are unable to say proper answer. Completely it is decreases or completely it is increases, or up to certain time increasing then decreasing, right? Up to third period, okay, certain time interval it is increasing then it is decreasing. But what about in D block and F block? No regular gradation. So that's why here you are saying in periods there is no regular tendency or regular gradation. Up to some group number it is increasing, that is 4th A. Then next what happens, it is going to decrease from 5th A to 8th A. So that calculation of valency of 5th A to 8th A group simply based on simple logical formula, that is here subtracting the group number from 8. Suppose if you want to find out the valency of 5th A group, what to do? 8 minus 5, that will give you 3. So 3 is the valency of 5th A group. 7th A group, suppose here the valence of seventh group is given as 1. Subtract group number from 8. 8 minus group number is 7. So 8 minus 7 will give you 1. So the valence of group 7A is 1. So here it is specially applicable for S and P block elements only. For D block, there is no regular gradation. Based on that D block and F block, you are giving your answer as no regular tendency in periods, but remains same in groups. Because why it is remaining same? Remaining same due to similar electronic configuration. Have you got the reason for increase and remain same or no regular tendency? Have you got a reason for them? Why it is remain same? Why it is in the no regular tendency? So this is the main, depending on outermost shell electronic configuration, right? This you need to understand. So one of the property we discussed how it is varying in the groups and in periods. So next one we will discuss about atomic size and atomic radius, right? So this is very important in understanding. If you understand atomic size concept completely, then remaining properties are very easy to you. To understand the next periodic properties, you need to get complete information about atomic radius. Complete understanding is required. So that I will discuss with you tomorrow in our next class, right? So if there is any confused topic,